We've also talked about similar figures, and similar figures are shapes that are the same shape, but different sizes. And those two sizes have to be in proportion to each other to be similar. So one's just a smaller version of the other one, one's a larger version of the other one, kind of like we talked about in scale drawings. And so first of all, to tell you that these are two similar triangles, I would say that triangle ABC is similar to triangle DEF. Now, we can use this information to find some missing sides. Remember, in similar triangles, the angles are the same. So if this angle here is equal to 60 degrees, then this angle here would also be equal to 60 degrees. But that's just kind of some side information, and I'm going to erase that because right now we're just working with sides. And to find a missing side in a similar triangle, I'm going to set up a proportion. So using this information that I'm given, remember a proportion compares two different ratios. So I'm going to prepare my fraction bar for my two different fractions. Now looking at triangle ABC, side AB matches up with side DE. And so that 20 inches for AB is in proportion to the 5 inches for DE. And if we look here, side BC matches up with side EF. So that 48 inches for side BC is going to be in proportion to that X inches, or that length I'm trying to find. Like any other proportion, I'm now going to circle my cross products. And I'm going to multiply those cross products. So 48 times 5 is equal to 220. Or 240 rather. 48 times 5 is equal to 240. And 20 times x is just equal to 20x. And I keep my equal sign there. Those are a proportion. And so 20x, or 20 times x, is equal to 240. And the opposite of multiplying a number by 20 is dividing by 20. So I'm going to divide my left side by 20. And to keep that scale balanced, I'll do the same thing on the right. 20 divided by 20 is just 1 times x, and 1 times x is just x. So in this case, x is equal to 240 divided by 20 is 12. So side EF is equal to 12 inches. I do also want to show you that I could have set up that proportion a little bit differently, and I could have said, again, side AB is the same as DE, and 20 inches is in proportion to the 5 inches that is on triangle DEF. And similarly, the 48 inches for side BC is in proportion to the X inches for side EF. And again, I'm going to circle my cross products. And I've ended up with the same thing as when I set up this first proportion. So 48 times 5 will still be equal to 240. And then I'll divide by that 20 here, and I'll still get 12. So either way, I could have set up that proportion to get the same answer of 12 inches as my missing side.